Today, I want to share with you a very practical Redshift rendering tutorial video. It is divided into two parts. One is VDB Cloud texture settings, and the other is rendering speed improvement. The model used by my current computer graphics card is RTX 3060. Although it is very old, it is so slow to render VDB Cloud. Then my rendering sampling parameters are still very low. Do you think this rendering speed is normal? By the way, rendering volumetric clouds does not require global illumination to be turned on, unless your scene has other objects, and I don't recommend that you render the VDB together to output animations. And the dimensions I'm testing now are just 1280 by 720. The entire scene is just using to area lights and a starry sky background. I'll show you the rendering time so that you can feel if my method is helpful to you. Now at a low sample 1280 by 720 size, the rendering time for a single volume cloud is 2 minutes and 14 seconds. That's a decent amount of time for a low-end graphics card like this. So let's test it on a bit of difficulty, first using the clone volume cloud random position and rotation and scaling. Note that volume cloud does not support rendering instances in clone mode. Only instances can be used, so the rendering will actually increase significantly. And Cinema 4D response speed and fluency will be greatly reduced. You can see that the clone cannot render the object correctly using the render instance. So how long does it take to render a volumetric cloud of the same size at this time? Keep your eyes open and don't be intimidated by this next test. And I'm going to show you the rendering process in editing software using a 100x speed up. The final rendering time is 15 minutes and 2 seconds. Did you refresh your cognition? Why does just a few more volume clouds cause the rendering time to run out of control? This is the problem I haven't solved using Redshift renderer in recent years. Today I will show you how to solve the problem. The image viewer has a comparison of the time I tested. This is the time it took me to render using the optimization technique. If you don't use a color volumetric cloud, the rendering time is even less than a minute. I also rendered a camera animation of a volumetric cloud for testing. The average rendering time is just over a minute. Can you imagine how exaggerated the difference in speed is? If you have a high-end graphics card such as the latest RTX 5090, the rendering speed will not be rendered in seconds. So without further ado, let's start our teaching time. First of all, I will explain the operation of VDB color map using the operation process of ordinary people. I'll give you a demo with a VDB file. You can make your own VDB. Because Redshift reads the display of VDB by default, it is just that the box cannot distinguish the specific form. So first use the point display to adjust the rotation property. Then create to area lights to simply illuminate the VDB. It is best to use the target tag, which can better control the lighting angle. Copy area lights to adjust position and intensity. Create Redshift volume material. And assign the material ball to the VDB object. Open the Redshift IPR rendering window and render the effect in real time. You can see that the default rendering speed is still very fast. First, adjust the layout of the Cinema 4D to facilitate our operation. Redshift now completely replaces the previous volume materials with standard volume materials. If you search for volume in the search bar, you can see the volume materials. The old version seems to have more volumetric material parameters, but the new volumetric material has its own advantages. And I'll show you what the difference is in a moment. You can see that the standard volume material has a lot of color attribute input, but the old version does not have. Then import the color map to color the VDB. It will not work correctly if the texture is directly attached to the color property of the scatters. Because VDB has no UVW information, it cannot map the map correctly. If you are a user of Redshift 2026.6 version, you are wondering if you can use the UV context function at this time. Then the operation was as fierce as a tiger, but it still didn't work. Is that the wrong way I connect to the texture? Is it okay to connect to the output? And it got even worse. I couldn't render it at all. So this is the detour I took to work on this process yesterday. The correct way should be to search for triplanar directly. Connect the map directly to the triplanar node and output to the color. Now you can see that the volumetric cloud has been colored by the map, but there are still some issues. The problem is not the triplanar node parameters, but the texture nodes. You can output the scale of the coordinate information bar and control it with a value. The default value is 0. Change the value to 0.002. Select the texture node and tick Mirror UV to eliminate the current hard edge. Finally, adjust the scale of the texture, and the specific parameters depend on your needs. Now let's talk about the volume material of the old version. Why can't this effect be achieved? Change the output material to the volume material of the old version for testing. Scatter first reads the density channel. Then tint is the parameter to color the volume. Do you think you can directly connect the sticker here? The reality is that older versions don't support this operation. If you are still using a version of Redshift like 3.6, this technology will not work. So that's the first bit of technology I'm going to talk about today. The second technical point is how to copy a large number of VDBs to improve rendering speed. I will demonstrate it with the thinking of ordinary users. What technical difficulties will be encountered? First, adjust the number and angle of clone volume clouds. Select Clone Object to add random effects. Enable 3 properties of influence position, rotation, and size. Now the view operation response speed is obviously a little bit laggy. And the rendering speed of IPR has also increased significantly. Even with global lighting turned off, it doesn't seem to improve rendering speed. The combination of low sampling and noise reduction did not improve rendering speed either. At this point, have you begun to suspect that your computer's performance is insufficient? I'll show you the pit I walked through again. View card issues can be adjusted to a bounding box by previewing the volume object in Redshift. And reposition the lights. However, the IPR rendering speed has not changed at all, and it is still extremely slow. Do you want to export the cloned object directly to the VDB object? Check Export to select Objects Only, then find that doesn't work. You just collapsed the clone in a fit of rage. Although it can be exported this time, I can tell you responsibly that the result is the same. Then you think of Redshift. Doesn't it have a proxy output function? Can you try it? Close all VDBs in the current scene and import the exported proxy file into the test again. Locate the clone proxy file you just exported. You can see the number of VDBs generated by the clone in the proxy file. Then hopefully the rendering speed will be improved. You can see that the IPR rendering speed has not changed in any way. It is the same slow. I am about to crash. Compare the rendering speed after my last optimization study. The IPR you're seeing here is timed up without any editing. Can you feel the difference in rendering speed? The same rendering parameters, the same number of clones, but the speed is worldwide different. As the saying goes, no harm without comparison. I almost doubt life. If you are interested in my teaching videos in this area, you can join my Patreon to watch. Thank you for watching. See you in the next video.